My name is Brad Burke. I'm a ready mix producer in Odessa, Midland, Hobbs, Texas, where it's very hot, long ways from here. And we've been using Dennis's system since about last June, and we're very pleased with the results. With that, I'll get going. Today I'm going to talk about the assurance for managing concrete consistency. One of the key things about this is it gives the ready mix producer opportunity to make more consistent concrete. We don't have to wait for that data to come back from the job site on the first load, and can get real data when that truck is fully mixed and starts heading to the job site. Our batch man can look at the panel and figure out where he's at. It is an operational efficiency tool. It doesn't really relate to most of what you're thinking technically here, but the remote monitoring aspects of this, which I'll get into, is very powerful for us and for me as somebody who has to look at ready-mix plants all over West Texas. How we track water, how we can track temperature, and give you I'm going to finish off with the best part, which is two real-world examples of projects that really had an impact for us as a company that I thought was very helpful. Now, consistency, making concrete consistent slump and air is much more difficult than anybody understands. We have drivers that can leave water in drum. They have drivers that can wash down at greater degrees than other drivers. Our moistures on our sand can fluctuate throughout the day and create a difficult consistency. And this is a tool that can help us see an adjustment when it's needed. So we got so many of these variables, and with varying water content, you get variability in entrained air. If we keep that slump and water content consistent, chances are we're going to have a greater chance to keep the air entrainment consistent as well. And irregular slumps causes problems for the finisher, as well as the end product that he's building for his customer. It can relate to irregular water content, irregular bleed, and the timing of how to finish that concrete. I always say the best finishers in the world are more artists than they are truly laborers. And people just don't understand that. They're dealing with different mix designs, cement contents, ternary blends, and they have to be able to figure out during the day with the varying weather conditions how the timing of that finish needs to take place. And that's a very difficult job, and I think a lot of people overlook that. And I believe that when we can make the product more consistent to the water content in the air, we're making a better, more consistent finished product and a higher quality product for the customers we serve. Real-time data on the probe system that we get is phenomenal. We get immediate feedback on that first load and know where it's slumping and where the temperature. This was really important in one of my critical projects that I'll talk more about at the end. And if we know the slump is correct, or whether or not we need to make adjustments. Does it look like it's providing the slump that's needed? Do we know, ask the driver, did you have any water left on from the last load? Or ask those things to get confirmation. Know if we need to adjust the hot water or a chilled water option, seeing what the temperature is running. Or maybe even look at some admixtures. Feedback while the load is en route. This is really helpful. If you see a trend of various trucks en route to the job site, we can quicker make adjustments at the plant. And then, of course, feedback once the load does arrive to the job site, and see how he's progressing in delivering that load and unloading, and see what the temperature and the slump was, and see what, how much slump loss did we have from plant to job site. Very powerful tool. And when you look at this is a truck. We can look at our GPS system, and it'll give us data on what the concrete temperature in the drum is, what the slump is, and if he's stopped and pulled over and added any water to adjust the slump, which is very important as well. but we can get that real data. The important thing is that the drum has to be operated between 2 and 3 RPMs, which is another incredible feature for us overall on safety. We do not want our ready-mix trucks driving down the road at 12 RPMs at mixing speed. That is a safety issue, and it's an added benefit of this system that we're seeing the drum speeds as they go down the road. If we don't see a slump measurement, we know that he's driving down the road at too high of RPMs, and could be a driver management issue with the plant manager as well. But we can look at them on site, we can look at them en route and see the trend and click on any of the icons of the trucks en route to the job site. Operational efficiency tool, probably not a highlight for the engineering community, but it is important to me as a ready-mix producer. What does it have to do with quality? Well, timely delivery is what gives us a higher quality. If we have to wait to adjust the loads or make adjustments, if we see the staging of the trucks using this tool, it forces us to do all the right things, forces us to take the proper moisture readings in advance, use the proper moistures, know what added water is being used. Avoiding stacked up trucks, integrated with the GPS system. If we see a series of trucks stacked up and we had a high profile project where we had a low water cement ratio and they're getting stacked up before the pump and we're using super, you know, that super could wear off by the truck that's stacked up, causing, and what's going to happen? What's the contractor going to do? Anyone? Anyone? Add water, exactly. So if we can adjust the timing of the delivery of the loads, we're going to make a much more consistent product. And we can adjust that and maybe look at our whole overall picture of other jobs and make a better quality product. We can make those adjustments at the plant and less adjustments on site to know, you know, when the truck gets to the job site, he's ready to pour. We're not having to stop, temper the water that's available for the load, and monitoring truck flow and remaining volume of each individual load helps us do the scheduling so we can give that consistent quality. And for me, the operational efficiency aspect of this product, cost justifies up for us to invest in this for our operation. And then all the other benefits are a win-win for everybody else in the teamwork aspect of building any project. Remote monitoring. As you see, this is kind of a little map of the area I cover. We got Lubbock up here, we got Fort Stockton, Pecos, Midland, Odessa. You might have heard there's an oil boom going on down there. It's kind of crazy. And then we got stuff into New Mexico, Hobbs. We basically got about a 2-hour radius. And I got to oversee all 14 ready-mix plants and 17 aggregate locations, pits and limestone quarries. That's my job. Can I be at everywhere when I want to be? Heck no. I can't be every place I want to be. But with this system, I can remotely monitor and make calls to key people on the job site. I can, you know, in fact, you can remotely monitor wherever you have internet. You can even set it up on a phone or a tablet. A lot of the people that I'm working with have tablets. I think that's in my future. If I don't see some information that I like, the beauty of it for me is I can call the batch plant. Hey, confirm, what's the slump look like? What are you using for your water content? What are you using for your sand moisture? I don't buy it. I can call the plant manager. Hey, so-and-so's driving down the road at 12 RPMs and I can't get a slump reading on his truck because he's driving unsafely. Or if I got a QC guy on staff confirming and dosing the super plasticizer, I can get in touch with him and he can put the eyes on and give me the information I know that I need to know. Okay, you need to up your dose of super, you know, to 4 ounces per 100 weight instead of 3. or give him the direction he needs that he might not be able to make those decisions on his own. But it's very powerful to have that remote access. Tracking water. I think this is probably the thing everybody knows. That's really important. And the system uses a flow meter to track water additions wherever they're at. And water is precisely measured. This is really important to the legal liability aspect of being a ready mix producer, because I can't tell you how many times I've gotten pissing matches with a contractor of who was responsible for adding the water. In the past, we had to rely on the driver, and the driver is going to use a sight gauge on his water tank or pull the lever and go 1001, 1002, 1003, a 3 count for a gallon or whatever, and we're going by a count. That's not precise, and that's not kosher, so to speak, with ACI. It has to be a precise measurement system. This is precise and gives us, and it's automatically documented. I don't have to rely on that driver to say 30 gallons was added. And quite frankly, I don't want the driver to write that down, because he frequently ends up getting in a conflict with the contractor. He said, well, I put in 20, only write 10. He doesn't want to get in an argument with the guy right there. We tell him what he's supposed to do. This takes him out of the equation. So whatever is documented is accurate. Now, if water's added, as Denny alluded to, there's 2 ways you can document it. One is the flow meter, but then also, if water is added from an outside source, you can see a change in the slump on the demand on the graphs. I'm going to show these. This is a pretty busy slide, and even for me that understands the system, it takes a while to go through it. But you have slump, temperature, water added, you have cumulative water added, you have a wide range of things you can look at, and RPMs. I'm going to just, to simplify things, I'm just going to show you the water added part of the graph. You can choose this. So what we have here is the slump. He mixed in, and the slump was there, and then he's mixing some more, and then there's the slump. Now, in this graph, this shows the blue spike is the water added. But say we didn't have, if it didn't go in from the flow meter, and the guy poured his own water from a fire hose or something, we would still have the spike and slump after the water was added and this was mixed. So we have little ways to document when water was added and the mix was altered in a different way. There's also a report option. I can't even begin to get through all the detail of what's available in the reports. This is a quick summary of what can be uploaded into Excel for reporting purposes. But if you look closely, this is truck 3150. This is just a small sample of all the data coming up into our Track-It system that's available to us, the ready mix producer, to analyze. And you can see his initial slump was 4.75. Total water was there. He added 2 gallons. Cumulative water, the water cement ratio was a 0.45. I know that mix is a 0.45, so we didn't violate it. Added 4 more. Cumulative water adds up to 6. Still haven't gone over 0.45. Okay, that wasn't enough water. The contractor decided to add 6 more gallons. Cumulative water is almost 13. Okay, now he's at 0.46. This mix is designed around a 0.45. And as you can see, he continued to add water to this point and got it up to a 0.49. Is this really going to cause a big problem? 9 times out of 10, probably not. And whether you want to believe it or not, stuff like this happens every day in the real world of ready mix. But they don't know about this stuff here, and they might have specified a 0.45, but they probably got a 0.49 in reality. So there's a lot of forensics we can do after a pour to see what's going on, and this is documentation. As you can see, it went up to a water-based slump of 6.75. So that's the report feature. Tracking temperatures. If it's too cold, we can adjust the hot water. When I was in North Dakota and Minnesota in the industry, we had very sophisticated hot water systems. We blend it with the cold water to dial in our exact temperature. I like to see it around 65 to 70 degrees in the winter. And when it was too cold, I could bring in the hot water content, but down and also suggest accelerators or non-chloride accelerators to the customer if he's worried about set time. If it's too hot, which is what I got to deal with now in North Dakota or in Texas, it's a bigger difference. We have chilled water systems and ice, so we can make an adjustment of our chilled water. We could increase the dose of retarder. If we see a trend on our concrete temperature on a longer haul, we might go from a lower dose to a higher dose. We can also look at prior day histories on what was the trend on the concrete temperature yesterday to predict what might happen today. This is my favorite part about the whole presentation I'm going to give. 2 projects. We had the Midland Holiday Inn in Midland, Texas. It was an elevated deck, kind of a tricky project. They needed 6,000 PSI. It's being poured late last fall in cooler weather. And the building was left idle since 2015, and they're completing it, and because of the change in the building codes, they had to go with a 12-inch monolithic second-floor deck to accommodate the HVAC system without extending the entire building by 30 inches to increase their beams thickness to accommodate the HVAC. So A, we're pouring in the middle of the night. B, I'm in Lubbock, Texas, because I had other responsibilities in Lubbock. It's being poured down in Odessa. And C, we got to have a low water cement ratio, make sure the drivers don't add additional water, and make certain that the contractor doesn't add water. The super's going in on right, and he's insisting we pour when it's 23 degrees. I'm also very concerned about the concrete temperature for this particular pour because I didn't have a lot of confidence in this contractor following ACI cold weather concreting guidelines. But I know if I got at least 50 degrees temperature, I would be okay. And we batched the concrete. I saw the initial reports. We were 44 to 46 degrees on the first load. By the time it got to the job site, there was one 49 degree, everything else was above 50. But I was able to document all that because the contractor insisted on going on a cold day, and we didn't have a hot water at that plant. And I was vitally concerned that if he's going to hang me if something goes south, and we couldn't prove we were at least 50 degrees. Well, we did get to 50 degrees. We tested the concrete. We got 7,800 on average in 28 days. Major success story. I saw times where I needed to talk to the plant manager about a driver, the field super for me on how's it coming in and get confirmation of the slump, that it was reading similar to what we said, and everything was going great. Another one, can't really talk about this project in a lot of great detail about whose it was, because this was an example of a potential liability situation for us. If you've been a ready-mix producer, it doesn't take long, and eventually you have a contractor that comes back at you, had a problem, and expecting you to pony up for the mistake he made. This was one of those types of examples. He calls me and says, hey, we got substantial plastic shrinkage cracks, and expecting us to give him a deduct so he can give a deduct to his owner and everything goes away. And we came up with that report. 20 gallons, 30 gallons. One load had 70 gallons of water documented on a 10-yard load used by his crew. I showed him that. We didn't have to have another conversation. So it's very powerful to have the documentation this tool gives us. Those are the 2 success stories I thought I'd give you. If anybody has any questions, Or if you want to email me at a later date, you can. That'd be great. Yes, sir.
How does people react to have a spy on their back all the time?
The drivers,
Human behavior, I mean.
the driver behavior is probably the toughest thing for us to change. But we also recently put in drive cams for the drivers. And one of the things that happened with drive cam is we documented idiots on cell phone cutting them off, and the drive cam technology saved their bacon from being in court saying, you know, it's the big bad truck, and it was actually stupid behavior documented by the cam. Same thing happens with the water addition. I don't have to chew them out to say, hey, you didn't write 30 gallons added on your ticket. Yes, sir.
Would you consider all this data proprietary information, or would you be willing to share with the client and the project owner?
It depends.
When, of course,
Yeah.
it goes south and there are claims to be made.
Correct.
Well, then-
I will know what the truth is, where the problem is.
Would you
So
share it with your owner, with the project owner?
I would be willing to do that. Yes, sir.
You mentioned RPMs as you're traveling down the road. Does
Correct.
it tell you RPMs, or you only know RPMs because you're not getting a slump reading?
No, if we want to look at the RPMs, that is a data point that is reported to us. But if I don't see a slump reading, 9 times out of 10, that is why. Is because he's outside of the range to get a proper reading. You'll get some slump readings when it's above 4 RPMs, but the most accurate are between 2 and 3. Yes, sir.
Do you have to calibrate your mix design based off of different mix classifications, different mix types?
There might be some specialty mixes we would require special calibration on, but most of them should fall into the template of our standard calibration.
All right, one more question from everyone.
So you kind of jump from kind of an opaque system to a fully transparent system, right? So was there a big learning curve with your plants having to have perfect moisture all the time, right? If you're gonna go up to somebody and say, you added too much water, but your sand moisture, your rock moisture were wrong, then it doesn't really matter, right?
Well, it gave me the hammer to get him to do perfect moistures every day. And that's what I want. I want what's best for the customer.